Okay, here we are. We made it. This is our last section of the semester, 11.5. Now, in this particular section, we are still dealing with logarithms, but here we're going to be dealing with a very particular, a very special base, and it's known as the natural base. Okay? The natural base involves a very special number, and it's an irregular number, and it is base E. E, in fact, is a number. If you were to look at your scientific calculators, you'll notice somewhere on your scientific calculator there is an e to the x key. It might be, you might need to use the second function to activate it, or you might find it under your log key. But somewhere on your scientific calculator, you'll notice this e to the x key, and that's the number e. And if you were to take e and raise it to the first power on your scientific calculator, you would see that you get that it's approximately, it's not exactly, but it is approximately 2.718. Okay? It does keep on going, on and on and on forever. It never repeats. There's no pattern to it. And that's why we consider E an irrational number. We dealt with irrational numbers before when we were talking about, like, let's say the square root of 2, or the square root of 5, or the square root of 11. Those were all irrational numbers because, once again, their decimal equivalents went on forever and they never repeated or had any pattern to it. So e to the first power is approximately 2.718. Now, of course, we can take e just like any other number and raise it to higher powers. If we were to take e, let's say, and square it, e squared would be the exact value. But if we were to use the scientific calculator and take e and raise it to the second power, we would get approximately 7.389. That would be the decimal approximation. I could take e and even raise it to a negative power. We, of course, know that means the same thing as 1 over e to the third power, using our laws of exponents and eliminating negative exponents. But if we wanted to come up with a decimal approximation for e to the negative third power, that would give you a decimal approximation of, let's say, 0.5 approximately. Okay? Now, what do we know about all these numbers here? One thing for certain here is that whether it be e to the first, e squared, e to the negative third power, all of these decimal approximations, these are all greater than 0. These are all positive numbers. And since they are positive numbers, we can use them with logarithms. And when we talk about a logarithm that involves base e, the natural base, we call that the natural log. Okay, because we're dealing with the natural base. When we're dealing with logarithms of base e, we refer to that as the natural log. And so there's an abbreviation for it. We could write log base e of, let's say, some number x. But mathematicians, you know how they are. They love their symbolic ways of writing this, abbreviations. So instead of writing log base e of x, they simply wrote the ln of x. Okay? ln, I usually write it in script, not to be confused with 1n. I usually write it as a script ln of x. So if you ever see that, the ln of x, that means the natural log, or log base e of x. Okay? And now we saw a lot of properties involving logarithms. You may recall we had properties that involved adding, subtracting, and multiplication of logarithms. And of course, those properties also hold true for natural logs. For example, if we have the natural log of m plus the natural log of n, in our last section, we talked about how we can simplify this expression. because if we want to eliminate the addition, we can, because we are dealing with log base e, and this would become the natural log of the product mn. If we had, let's say, the natural log of m minus the natural log of n, that also can be simplified into the natural log of m divided by n. Or if we had the natural log of m, and that was being multiplied with a number. Recall once again what we can do with the number being multiplied. In fact, that becomes a power, and that would give us the natural log of m to the p power. So these properties of involving addition, subtraction, and multiplication, they worked not only for, let's say, log base 2, log base 7, log base 10, but they also work for log base e, otherwise known as the natural log. That's what that ln stands for. So for example, if we had the natural log of 5 plus the natural log of 7, we can simplify that into the natural log of 35, because remember, you have to take the 5 and multiply it with the 7. If we had the natural log of 40 minus the natural log of 5, that would equal now, of course, the simplified the natural log of 40 divided by 5, which of course would give us the natural log of 8. That would be your simplified natural log term. If we had, let's say, for example, negative 4 times the natural log of 2, that would give us now the natural log of 2 to the negative 4th power. And what could we do with that? Well, we could simplify, because we don't like having a negative power. So that would give us the natural log of 1 over 2 to the 4th. And we would want to even simplify that further, and that would give us the natural log of 1/16 as your simplified expression. If we can simplify with natural logs, we of course can also expand like we did with logarithms. For example, if I asked you to expand the natural log of 10x, that of course would be the same thing as the natural log of 10 plus the natural log of x, because anything that's being multiplied can be expanded out to the addition of two logarithmic terms. If I had the natural log of x over 5, that also can be expanded into the natural log of x minus the natural log of 5. Once again, because if something is being divided, we can expand that out into subtraction. If we had, let's say, the natural log of x to the 3rd power, well, we could expand that as well, because your power can be brought out into the front, and we would write that as 3 times the natural log of x. Okay? These would be considered your expanded forms, because we had a singular natural log expression, and we expanded it out using those properties that we had earlier. So we can either simplify or we can expand. Okay? One other thing that we can do with natural logs is that we can solve equations. Okay, just like before when we had equations with logarithms, we can solve equations with the natural log function. For example, let's say we had the following. The natural log of x is supposed to equal 4. Well, what does the natural log really mean? The natural log means that we are dealing with a log base e, okay? Log base e of x is going to equal 4, because log base e and the natural log mean the same thing. This is just the abbreviated way of writing it, okay? So if you see the natural log, that means log base e of x equals 4. And now, once again, just like we did in our section 11.2, I believe it was, when we were dealing with logarithmic equations, we wrote them in exponential form. And that would give us e to the 4th power equals x. And that would be your exact value. Because e is a number, all we are doing is raising that number e to the 4th power. I don't want you don't have to go to your calculator. You don't have to give me a decimal approximation. We are looking for the exact value. Okay, that's what the exact value of x would be. If we had another example, let's say the natural log of maybe x minus 2 equals 5, and we want to solve this for x. Well, once again, what does the natural log really mean? But log base e of the expression x minus 2, that is supposed to equal the number 5. So now we have logarithmic form. Let's take now the logarithmic form and write it into exponential form. Exponential form tells me to take the base e, raise it to the 5th power, and that has to equal x minus 2. Now we have to get x by itself, and right now x is being subtracted by the 2. So let's add the 2 over, in which case now we would get x equals e to the 5th plus 2 more, and that would be the exact value of x. Let's just try one more. If we have the natural log of the quantity 2x plus 5, let's say this equals the number 7. Okay, we want to solve for x. Well, once again, keep in mind that when you see the natural log, that is just an abbreviation for log base e of that 2x plus 5 is supposed to equal 7. And so now, what we need to do, once again, is just rewrite our logarithmic equation into the more familiar exponential form. So we take base e, we raise it to the 7th power, and that is supposed to equal 2x plus 5. Now we want to solve for x, get x by itself. I would have to start by subtracting 5 from both sides. That would give us e to the 7th minus 5 is going to equal 2x. And so now we would divide both sides by 2, in which case x is now equal e to the 7th minus 5 divided by 2. Okay? So natural log is very similar to the other logs that we talked about. The only difference is we are dealing with a very specific, a very special, a very irrational base, the natural base, base e. Okay? That's everything for section 11.5. Don't worry about graphing logarithms, okay? That won't be on your exams. So don't worry about knowing how to graph logarithmic equations. The only thing that you'll have to be able to graph on your exam is the exponential equation, like 2 to the x power, 3 to the x power, or maybe 1/4 to the x power, okay? That's all the new material. You have your exams coming up. You have your 4th exam. That will be on chapters 10 and 11. And then you will also have your final exam, okay? Shortly, you will receive both of those reviews, so this way you could start preparing for those exams as well, okay? Do take some time going over the homework that goes along with this, and please feel free to email me your questions, as some of you already are doing. That's great, okay? And hopefully you are understanding the replies to the emails that you send to me. I usually try to work out the problem for you and send you a picture of it, and hopefully you find that useful, okay? that's it as far as the lectures go, and that's pretty much it. So feel free to shoot me any questions, and until the next time, be well.